Hello everyone! In this video, we'll be introducing if statements. If statements are really great because they allow us to use something called conditional execution in our programs. And what that means is that on one running of the program, we might see one set of output, but on another running, we might see a different set of outputs. In order to demonstrate if statements, we're going to use something called pseudo-random numbers. And to get those, we're going to use a pseudo-random number generator. And this uses the rand function from the standard library. So the prototype and the libraries are shown here on this screen. What rand does is it produces a pseudo-random value that is an integer. So it only produces whole numbers. And in order to use that, we're going to include this preprocessor directive, include the standard library. So let's go ahead and take a look at it. In our preprocessor directives, we're going to add that line. We're going to include the standard library. And that gives us access to the pseudo-random number generator and a couple of other cool things. To hold our pseudo-random value, we're going to create an integer. I'm going to call mine num for number. And we'll call the rand function. And that will store a random value between 0 and 32,767 into this integer space called num. So in order for us to see it, we're going to print out our value. And say that our random number is num. And that's it to start with. We're going to create a random number and print it out so we can look at it. So we're going to build and run, and we're going to see that our random number is 41. Cool. Let's try it again. So we're build and run again, and we're going to see that our random number is 41. Let's try one more time. We're going to run it again. And we're going to see that our random number is still 41. So the reason it's always coming up the same is because there are no truly random numbers. The rand function produces a pseudo-random value that's based on a formula. To produce a reasonably random value, it has to have a starting point known as a seed. If no seed is given, then the same starting point is always used, hence us always having the same number. So we could give it an explicit seed, but then we would need to change the seed every time we wanted a new number. A better solution is to use the computer's internal clock to seed the pseudo-random number generator, which we can do using these two functions. The srand function stands for seed random, so that we'll use that to seed our pseudo-random number generator. And time, the time function gives us a value based on the computer's internal clock, which updates every couple of seconds. So we can seed this pseudo-random number generator in this way. Seed rand based on the time from right now. So if we go back to our function and we seed the pseudo-random number generator, we have to include the time library in order to use the time function. So we're going to include time.h. So we'll seed the pseudo-random number generator based on the current time. And if we run our program again, now we have a new random value. Well, this one's quite large. So if we want to control the range of our pseudo-random number, we can use the mod operator. If we do it this way, if we mod by 100, we'll get a pseudo-random number from 0 to 99. Because remember, mod produces the remainder if we divide one number by another. So if we mod by 100, all possible remainders are 0 to 99. There's 43. There's 60. So cool things like that. So we can create any kind of range we're looking for using mod. there's 13. Another thing that's cool is we only need to seed the pseudo-random number generator once. We can use it as many times as we wish. We can print these out to see what they look like. And see that they'll all be different. They'll all be pseudo-random. And the ones that we can strain with ranges will be in between those ranges. So this one's between 1 and 100. This one's not constrained at all, so it's between 0 and 32,000. And this one is going to be between 0 and 249. So what we're going to do with this is build a little guessing game where we generate a secret number and we ask our users to guess what it is. And in order to be able to tell them whether or not they're right, we're going to need something called a conditional expression. Now if you've programmed before, you may recognize this as a Boolean expression. However, C does not have a Boolean type, so we call them conditional expressions. This is the general syntax. We have two expressions separated by a relational operator. Now the expressions have to match in type, meaning they should both be numerical expressions, but we can use characters as well. We can't use strings, so we'll talk about strings later on. They have their own special chapter. Here are the 6 relational operators that we can put in our conditional expressions. We have equal to, not equal to, greater than or equal to, less than, and less than or equal to. And we'll see some examples to see how they work. These conditional expressions are going to produce a value that is either true or false. Since we don't have a Boolean type, we represent true with 1 and false with 0. Okay, so now given these values for some integers, we've got x is 4, y is 12, and z is 21, we're going to figure out what these would evaluate to. So this relational operator is equal to, these are two integer expressions, and we're essentially asking, is x equal to y? Well, since x is 4 and y is 12, no, it is not. So that would be false or 0. Let's try the next one. This is x times y greater than z. So we would do x times y first. So we'll do 4 times 12. We'll get 48, which is greater than 21. So that's true. The third one says y not equal to z, and since y and z are not equal, that'll be true. Fourth one says x plus z greater than or equal to 25, so first we'll do x and z. We'll add x, which is 4, to z, which is 21, which is 25, and see that it is greater than or equal to because they're equal, so that one's also true. This fifth example asks if y is less than x. It is not, so that'll be false. And the final one says, is z mod y less than or equal to x? So first we have to do z mod y, and that'll be the remainder of 21 divided by 12. So 12 goes into 21 one time, with 9 left over, so is 9 less than or equal to 4? It's not, so we'll get false for that one too. Alright, so now we can put these together with what's called an if statement. It essentially reads, if the conditional expression is true, then run this statement. If the conditional expression evaluates to false, the statement will not be run, and the program will just continue sequentially after that statement. So we're going to take these and put them together with the random number generator to create a simple guessing game. We already have all of our necessary libraries. Here's our standard input-output library, the standard library, which has the random function and the seed random function, and the time library. We're going to need the secret number and the user's guess. We need to seed the pseudo-random number generator. And then we're going to create the secret number. We're going to keep it relatively simple since in this case they only get one guess. So we're going to make it a value between 1 and 10. So modding by 10 gets us values 0 through 9. Adding 1 shifts that range up 1 for 1 to 10. So now we're going to prompt the user for their guess. We'll have them guess a value. We're going to go ahead and give them in the range so that they're not guessing any integer they could think of. Tell them it's between 1 and 10. And then we're going to read in their guess, and we'll store that in guess. So now we need to check to see if they got it right. So if their guess is the same as our number, then we can print out, you guessed the number correctly. Yay! It'll just be a really simple game, so we're going to go ahead and try it out. It'll print our prompt. It says guess a value between 1 and 10, and we'll guess. And we must not have gotten it correctly because nothing printed out. So if guess does not equal num, so if the conditional expression does not evaluate to true, then it won't print anything else. So at the moment we're not providing any context for a user as to whether or not they got it right. They don't see anything after their guess. But they also haven't been told that their guess is wrong. So we're going to go back and see a way that we can add in a message if the conditional expression is not true. And this is called an if-else statement. And what we would do is we would say, if the conditional expression is true, run statement 1. If not, run statement 2. So in this setup, we're only ever going to run one of these statements. We'll run statement 1 or statement 2, but never both. So if the conditional expression is true, run statement 1. If not, run statement 2. So we're going to use that for our guessing game. If the conditional expression is true, print out you guessed the number correctly. Else, print out otherwise they did not guess the right number. In this way, the user will always get a message regardless of what they typed in. They'll know whether or not they guessed it correctly. So we're going to go ahead and check this out. We'll run it again. The pseudo-random number is 6 at the moment, so it's told us we guessed the number correctly. We're going to try again. We want to be able to see both messages, so we want to try. So now if we guess it incorrectly, it'll tell us, sorry, you did not guess the right number. Cool, so now we've seen both executions. Now at the moment, only one statement can be executed based on the conditional expression. So if guess is equal to num, we can do this one thing, which is printing. So if we'd like to do more than one thing, then we're going to add these braces to our statements in order to create statement blocks. And what the compiler does is it treats all of these things in between sets of braces as a single statement syntactically. So what we would say here is that if the conditional expression is true, run all of the statements in this set of brackets. And if it's not true, run all of the statements in this set of brackets. So let's take a look real quick what that would look like. Let's say for our else statement, since they didn't guess it correctly, we're going to let them know what the number actually was. So if they guessed it correctly, then we'll print out, you guessed the number. But if not, we'll print two different statements. We'll say, sorry, you didn't get the right number, but here's what it was, just so it's not a big mystery forever. Okay, so now if we don't guess the number correctly, it says, sorry, you did not guess the right number. The number was actually 10. Okay. Now it's your turn. Write a program that determines if the user can apply for their driver's license. So ask them to enter their age. If it's 16 or higher, then they can apply. Otherwise, they have to wait. If they have to wait, print out how many years they still have left. So go ahead and try out this practice program. Then you can look for my solution on the web course. And in our next video, we'll look at some more complex conditional expressions. See you then.